Hello and welcome back to another IB Math Speedrun with me, Vince. In this one, we're going to be going through equations of vector lines in 3 dimensions. So let's jump right in. So in 3 dimensions, most of the stuff all of the stuff from 2 dimensions carries over. So we have a point is equal to usually a plus, and then we usually use lambda d in 3 dimensions. Like for the parts we multiply to the direction vector, we use the symbols lambda, mu, and usually. And so this is of course equal to x, y, z. It's equal to x1, y1, z1 plus lambda times d1, d2, d3. And then so again we could rearrange this in parametric form. X is equal to x1 plus lambda d1, y is equal to y1 plus lambda d2, and z is equal to z1 plus lambda d3. And so similarly, we can rearrange this to get the equation of a line. So we have x minus x1 over d1 is equal to y minus y1 over d2 is equal to z minus z1 over d3. So this is the Cartesian form. And so there is another thing we need to note, and it's the relationship between 2 lines in 3D space. So in 2D space, 2 lines can be parallel, or they can intersect at one common point. Now in 3D space, there's a third case where lines are skew, and it's a bit, how do we draw this? Something like this, where these lines aren't parallel. Like if we have, this is y, this is x, and this is z. Then we can have one line going here and one line going here, and this top line, there's a distance in the y value between this top and bottom line. So they never actually intersect. This is just an illusionary intersection point. And so how do we show that 2 lines are skew? Well, first of all, they cannot have the same direction vector, so they are not parallel. And 2, they never intersect at a point. So if we can prove that they are not parallel and they don't intersect at a point, we can prove that 2 lines are skew. With that being said, let's jump into some questions. So first, find the vector equation of a line passing through the points 1, 3, -2, and 4, 2, 1. So this is equal to x, y, and z is equal to lambda, and then, well, we need to get the difference. So 4 and 1 is 3, 2 and 3 is -1, 1 and -2 is 3. And then we can add it to the position of one of the points. I'm going to pick 1, 3, and -2. So this is how you get the equation of a line from 2 points in 3D space. Okay, next, we're given the question, the line r is equal to 3i minus j plus 2k plus lambda -i plus j plus 3k, where of course lambda is a real number, is given. So we need to do a bunch of things. First, we need to show that the point P, which is 0, 2, and 5, does not lie on the line. B, find the equation of the line parallel to it that passes through the point P. C, for what value of a does the point lie, that point T -2 for a lie on the line. Okay, so in order to show that this point doesn't lie on the line, we're going to have to convert into parametric. So this is equal to x is equal to 3 minus lambda. Y is equal to -1 plus lambda, and z is equal to 2 plus 3 lambda. So we can substitute these values in 0, 2, 5. So if we have x is 0, so lambda equals 3. And then we have y is equal to negative 1 plus lambda. So negative 1 plus 3 is equal to 2. So, okay, that point does lie on the line. So this is equal to 2. But then for the last point, 5. 5 is not equal to 2 plus 3 times 3. It's not equal to 11. So therefore this point doesn't lie on the line since it doesn't satisfy these three equations. Okay, so that's number 1. Number 2 is find the equation of the line parallel to it so it passes through the point P. So a line parallel to it would have this same part over here, so and then we can just simply make it pass through the point P. So this would be equal to what form do they want us to put this in? In column vector form. Okay, so we have negative I, 3j, so we can say a parallel line x, y, z. It's equal to negative 1, 1, 3 times lambda plus this point, whatever point, 0, 2, 5, so ensuring it passes through the point. So yeah, this is a line parallel that passes through the point. And then finally, we need to find for what value of a does the point t lie on the line. Okay, well, we need to go back to the parametric form. X is equal to negative lambda plus 3, y is equal to lambda minus 1, and z is equal to 3 lambda plus 2. So the point negative 2 for a lies on the line. So we have negative 2 is equal to negative lambda plus 3. So lambda is equal to 5. Y is equal to lambda minus 1. 5 minus 1 is equal to 4. And so finally, we need to find the value of 3 lambda minus 2. So 3 times 5 plus 2, sorry, not minus 2, is equal to 17. So a must equal 17 for this point to be on the line. Okay. Where are we? Yep, a is equal to 17. Nice. Okay, next question. We have find any points of intersection between the following lines. The first line is equal to x minus 3 over 5 is equal to y plus 2 over 4 is equal to z minus 1 over 3. And the second line is equal to 7 minus x is equal to y minus 4 over 2 is equal to z plus 1 over minus 3. And so there's a bit of a trick when we're converting back from this kind of form to a parametric form. If there are no coefficients in any of x, y, and z, this is simply equal to says x is equal to 3 plus 5 lambda, y is equal to 4 lambda minus 2, and z is equal to 1 plus 3 lambda. Similarly over here, we have x is equal to 7 plus lambda. Yeah, because, wait, hold on. Negative x is equal to negative 7 plus lambda. Oh, so this is 7 minus lambda. Y is equal to 4 plus 2 lambda, and z is equal to negative 1. Oh, this is minus 3 lambda. So anyways, from this we can try equating them. So if we have 3 plus 5 lambda is equal to 7 minus lambda, we have 6 lambda is equal to 7 minus 3, 4. Lambda is equal to 2/3. So let's try. So we have 4. We need to check whether 4 times 2/3 minus 2 is equal to 4 plus 2 times 2/3. So we have 2 times 2/3 is equal to 6, which is not correct. 4/3 does not equal 6. So therefore, I don't think these points have any points of intersection. So these lines don't intersect, since if we have the same x value, they have different y values. Okay, next we need to check whether the lines L1 is equal to x over 2 is equal to y minus 2 over 5 is equal to z over 4. And we have line 2 is equal to x minus 1 over 2 is equal to y plus 1 over 2 is equal to z plus 3. So let's rewrite these in parametric form. That's not a negative sign. So what we have is we have x is equal to 2 lambda, y is equal to 2 plus 5 lambda, and z is equal to 4 lambda. And then over here we have x is equal to 1 plus 2 lambda, y is equal to negative 1 plus 2 lambda, and z is equal to negative 3 plus lambda. So if we equate these two, we get lambda equals 0, since 2 lambda equals 1 plus lambda. But since 2 does not equal 1, just looking at the y values, 2 plus 5 lambda and 1 plus 2 lambda, then therefore these lines don't intersect either. Sorry, I've misread this. This is a 3. So this is actually 1 plus 3 lambda. Oopsies, so let's see again. So we have 2 lambda equals 1 plus 3 lambda, so negative lambda is equal to 1, lambda is equal to negative 1. So we have 2 minus 5 is equal to negative 1 minus 2, which of course it does equal. This is fine. And so we have z is equal to negative 4 is equal to negative 3 minus 1. Okay, so actually all of these lines do intersect. And so they will intersect at the point where lambda equals negative 1. Sorry, actually these should be different values. Yeah, oops, sorry. We should be labeling these mu, because they are not necessarily equal. Oops. But anyways, we got 2 lambda is equal to 1 plus 3 mu. So lambda is equal to 1 plus 3 mu over 2. So we have 2 plus 5 lambda, 2 plus 5 times 1 plus 3 mu over 2 is equal to negative 1 plus 2 mu. So we have 5 times 1 plus 3 mu is equal to negative 6 plus 4 mu. So we have 11 is equal to negative 11 mu, so mu is equal to negative 1. And so lambda is equal to 1 minus 3, so it's negative 2 over 2 is negative 1. So yeah, I mean they are both equal, which is why we accidentally got the correct answer in the first one. So to find the coordinates of this point, this would be negative 2, 2 minus 5 is negative 3, and then negative 4. So these lines would intersect at this point, negative 2, negative 3, and negative 4. So yeah, they do intersect indeed. So that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one. See you then.